Today we are going to discuss about the collision. Actually, what is collision? Collision mean mutual interaction of two or more bodies, and after a short interaction is there. After interaction, what happen? Their direction is they change or they are scattering. They are in different direction, and also their velocities are changing. So mutual interaction of two or more bodies. After that, short interaction should be there. After that, what happen? They are scattering with different speed in different direction. Okay, that is called collision. So see here, if a system we have taken, isolated system we have taken, and no other external force are acting on the system, so we know total linear momentum is conserved, because F force is equal to rate of change of momentum. If external force upon any system is 0, F external is equal to 0, that means dp upon dt is equal to 0. Rate of change of linear momentum 0 mean p is equal to constant. So see here, in collision what are happening, net external force upon the system is 0, that's why linear momentum is conserved. To see what is collision, collision means any short interaction of particles or bodies either through direct contact or otherwise, and scatter in different direction, so that is called collision. See here, during collision the linear momentum of entire system is conserved if there is no external force is acting on the system. That's the second thing. Total energy of the system is also conserved. But when we are talking about the kinetic energy, so kinetic energy may be conserved, may be not conserved. So remember one thing, in collision what are happening, total energy is conserved, but kinetic energy of the entire system may be conserved, may not be conserved. So see here, by terms of kinetic energy, conserved or not conserved, we are dividing the collision mainly two types. One is what, elastic collision, and other is what, inelastic collision. To see what I have told you, total linear momentum is always conserved, but kinetic energy, total energy is conserved, but kinetic energy may be conserved, may be not conserved. During the interaction, maybe kinetic energy converted in the forms of heat energy, there is loss of kinetic energy. So see, when elastic collision is there, so what happens? Kinetic energy is conserved. If kinetic energy is conserved, what we are saying, that type of collision is elastic collision. So what is elastic collision? The collision in which kinetic energy is conserved, and we know linear momentum is also conserved. So you can say in elastic collision kinetic energy is conserved, and linear momentum is conserved. This is for elastic collision. For inelastic collision, what happened? What I have told you, kinetic energy is not conserved. Kinetic energy is not conserved. Collision, if kinetic energy conserved, elastic. Kinetic energy not conserved, inelastic. And collision, you know, linear momentum is conserved and total energy is conserved. Then all in inelastic collision, linear momentum is conserved. One more type I have shown here, perfectly inelastic. Actually, perfectly inelastic mean if after collision all bodies yeah, all particles moving with same velocity. सभी पार्टिकल्स सेम वेलोसिटी से मूव कर सकते हैं यार. यू कैन से कि ऑल पार्टिकल्स आर स्टिकिंग एंड दे फॉर्म वन बॉडी. ठीक है, तो उसे हम क्या कहते हैं बेटा, परफेक्टली इनइलास्टिक. परफेक्टली इनइलास्टिक मीन आफ्टर collision all particles, hard particles are body moved with same velocity. Hard particles will move with same velocity, mean that is all particles sticking each other. So that is called inelastic collision. And in inelastic collision kinetic energy loss is maximum. Here kinetic energy loss will be maximum. So remember these things. What is collision? In collision, linear momentum is conserved, total energy is conserved, but kinetic energy may or may not conserve. Second thing, for elastic collision, kinetic energy is conserved, linear momentum तो conserved होता ही है. इनइलास्टिक में काइनेटिक एनर्जी इज नॉट कंजर्व्ड बट लीनियर मोमेंटम तो कंजर्व्ड रहेगा ही. एक परफेक्टली इनइलास्टिक इफ आफ्टर कोलिजन ऑल पार्टिकल्स स्टिकिंग ईच अदर मीन दे विल मूव विद सेम वेलोसिटी. तो हम क्या कहेंगे बेटा, दैट इज कॉल्ड, हमें क्या कहते हैं, परफेक्टली इनइलास्टिक. ऑल पार्टिकल्स जो है कंबाइनिंग हैं, कंबाइंड दे विल मूव टुगेदर. ठीक है, तो उसे हम क्या कहते हैं, परफेक्टली इनइलास्टिक कोलिजन. सी व्हाट इज कोफिशिएंट ऑफ रेस्टिट्यूशन? कोफिशिएंट ऑफ रेस्टिट्यूशन मीन द नेगेटिव ऑफ द रेशियो ऑफ रिलेटिव वेलोसिटी ऑफ सेपरेशन टू रिलेटिव वेलोसिटी ऑफ अप्रोच. देखो बेटा, कोफिशिएंट ऑफ रेस्टिट्यूशन मीन क्या होता है, रिलेटिव वेलोसिटी ऑफ सेपरेशन जो है और रिलेटिव वेलोसिटी ऑफ अप्रोच, उनका जो है क्या होगा, रेशियो, लेकिन उसका हम नेगेटिव साइन लेते हैं. तो व्हाट इज कोफिशिएंट ऑफ रेस्टिट्यूशन? रेशियो ऑफ रिलेटिव वेलोसिटी ऑफ सेपरेशन टू रिलेटिव वेलोसिटी ऑफ अप्रोच. इट इज नेगेटिव साइन ऑफ दैट, इट इज डिनोटेड बाय E. तो सी, अगर सपोज एनी ऑब्जेक्ट इज देयर m1, his velocity is u1, in other object m2 velocity is u2. So what happened? What will be the relative velocity of approaching? The relative velocity of approaching is what? u2 minus u1. Same way after collision what happened? m1 and m2 here collided, and after collision m1 has velocity v1, m2 has velocity v2. They have collided. After collision they are separating with each other. So what will be the relative velocity of separation? So that is v2 minus v1. So see here, what is E? Minus v2 minus v1 upon u2 minus u1. This will be the coefficient of restitution. Suppose all objects are moving in a straight line in same direction. What happen? V2 you can say as speed is v2. We can take this is v1. This is also u2 minus u1. The minus sign I have taken here. So E is equal to v2 minus v1 upon minus sign I have multiplied u1 minus u2. If all masses moving in a straight line, same direction, we can see here E is equal to V2 minus V1 divided by U1 minus U2. So what is the coefficient of restitution? It is negative of the ratio of relative velocity of separation to relative velocity of approach. Here also we can see, here we have taken in speed form. So E is ratio of relative speed of separation to relative speed of approaching. See here, when we are talking about the elastic collision, okay, so for elastic collision what are happening? So for elastic collision E is equal to 1. Relative velocity of approaching is equal to relative velocity of separation. So for elastic collision what happen? For elastic collision E is equal to, because V2 minus V1 is equal to U1 minus U2, that's why what happen, their coefficient of restitution is 1. That this is for elastic collision. For inelastic collision what happen? For inelastic collision it is less than 1, because V2 minus V1 ratio it comes less than 1. See here, for perfectly inelastic collision to see all have same speed, all particles mean V2 is equal to V1. So V2 is equal to V1 mean what happened? V2 minus V1 is equal to 0. So for perfectly inelastic E is equal to 0. One also you can say super elastic, in which after collision speed will increases. So there maybe for super elastic collision we can see E is greater than 0 or greater than 1. So this will be the for coefficient of restitution. Here we are discussing inelastic collision in one dimension. So see here, two objects of mass m1 and m2 having a speed u1 and u2, and they are moving in a straight line, and inelastic collision is there. So find what will be the speed after inelastic collision. What will be the v1 and v2 after collision? They have given E is the coefficient of restitution. So see here, what we have told, in elastic collision kinetic energy conserved and linear momentum is conserved. But when we are talk about the inelastic collision, what happen? Momentum is conserved, but kinetic energy, there will be loss of kinetic energy. Kinetic energy is not conserved. Kinetic energy loss is due to sound energy or heating energy in the form of heat energy. To see what will be the velocity after collision. To see momentum is conserved, linear momentum is conserved. So this means initial momentum is equal to final momentum, mean initial momentum m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2, as they are moving in a straight line. So all we can write in the scalar form. This is first equation. Second, what is E, coefficient of restitution? So E is equal to what? Relative velocity of separation to relative velocity of approaching. So this implies V2 minus V1. This we have taken left hand side, E u1 minus u2. This is the relation between velocity of approaching to velocity of separation. So we have to find V1 or V2. So put here V2 is equal to what? V1 I have taken right hand side, so V1 plus EU1 minus EU2. So see, this is suppose second equation. So this we are putting in first equation. Put V2 in equation 1. What happened? M1 U1 plus M2 U2 is equal to M1 V1 plus M2. In place of V2 we have put it V1 plus EU1 minus EU2. See here, solve this, multiply M2, M2E, this is M2E U1, M2E U2. We have to find V1. To put all these, you will take left hand side. What happened? M1 U1 plus M2 U2. This I have taken left hand side. M2E U1, M2E U2. This I have taken. So this becomes minus, this becomes plus. Here M1 V1 plus M2 V1. So V1 we will take common. So here we can see M1 U1. So this U1 I have taken common. So what will be the remaining in these two? So M1 minus EM2. And another, here you can see M2U2, M2U2. So this M2U2 I have taken common. So what will be the remaining? Here 1 plus E is equal to V1 I have taken common, M1 plus M2. What we have seen? What will be the V1? V1 is equal to what? This you will take left hand side. Then what happened? M1 E M2 plus 1 plus E M2 U2 divided by M1 plus M2. So this is the V1. V1 we can see here. This V1 is what? V1 का क्या फॉर्मूला मिला हमें? V1 is equal to M1 minus EM2 1 plus E M2 U2 upon M1 plus M2. If you are putting V1 in the first equation, तो see V1 what we have finded? V1 का रिजल्ट क्या है बेटा? V1 का अगर हम रिजल्ट देखें, ठीक है, सॉरी हियर U1. तो V1 का क्या रिजल्ट आया? M1 minus EM2 bracket U1 1 plus E, that is M2 U2 divided by M1 plus M2. So this is the velocity of particle object after inelastic collision. This is V1. If V1 we are putting in this equation, we can find V2. So V2 is equal to what? From equation 2, V2 is equal to, in place of V1 you will write all these, M1 minus EM2 U1 plus 1 plus E M2 U2 divided by M1 plus M2 plus E U1 minus E U2. So you will simplify same way. What you will got? The V2 is equal to, you will take LCM and simplify it, you will get same formula like that. M2 minus EM1 U2 1 plus EM1 U1 divided by M1 plus M2. So this will be the equation for V2. Yeah, very simple. V2 is equal to M2 minus EM1 U2 1 plus EM1 U1 upon M1 plus M2. We will see later for elastic collision E is equal to 1. तो elastic collision के लिए अगर हम बात करें तो for elastic collision what happen? For elastic collision क्या होता है बेटा? E is equal to 1. तो if you are putting E is equal to 1, तो you can also find the formula of elastic collision like that. E is equal to 1, तो क्या होगा बेटा? M1 minus M2 U1, यहाँ पर 1 plus 1, this is 2 M2 U2 divided by M1 plus M2. So this is the formula for elastic collision. ठीक है, तो इन इलास्टिक कोलिजन के लिए व्हाट विल बी द वेलोसिटी, क्या वेलोसिटी होगी, हम क्या कर सकते हैं बेटा? फाइंड आउट कर सकते हैं, याद कर सकते हैं, रिमेंबर कर सकते हैं. दिस इज V1 एंड दिस इज V2. Just see here, what we have told, in elastic collision there is loss. ठीक है, loss of kinetic energy. तो we can also find the loss of kinetic energy. Mean final kinetic energy half m1 v1 square. यानी what will be the loss of kinetic energy? Loss of kinetic energy mean initial kinetic energy minus final kinetic energy. तो initial kinetic energy mean half m1 u1 square plus half m2 u2 square. This is initial kinetic energy. And what will be the final kinetic energy? Half m1 v1 square plus half m2 v2 square. If you are putting all v1 v2's value here and simplify, you will find loss of kinetic energy. तो एक फार्मूला बेटा आता है, वो क्या आता है, अगर सिंप्लीफाई करोगे v1 v2, मैं प्रूफ नहीं कर रहा, ठीक है, उसको रख करके आप सिंप्लीफाई करोगे तो यू विल गेट लाइक दैट फार्मूला हाफ m1 m2 upon m1 plus m2 bracket u1 minus u2 whole square and 1 minus e square. So this is the formula for loss of kinetic energy. तो इस फॉर्मूले को हम याद करके रख सकते हैं कि लॉस ऑफ काइनेटिक एनर्जी ड्यूरिंग द inelastic collision half m1 m2 upon m1 plus m2. This is also called reduced mass. ठीक है, u1 minus u2 square 1 minus e square. ठीक है, this is initial kinetic energy minus final kinetic energy. Actually these come positive quantity because these are positive, square positive, e is less than 1, so this is also positive. Mean kinetic energy of first minus kinetic energy of second is positive quantity. That's why we can say there is loss of kinetic energy. So there, here we have seen, ठीक है, for inelastic collision in one dimension how we can find the relation of velocities. वेलोसिटीज के रिलेशन हम कैसे फाइंड आउट कर सकते हैं, उनका क्या फार्मूला होगा, ठीक है, these two formulas. And what will be the loss of kinetic energy during the inelastic collision.